Hello all, my name is Sonali and today I'll be talking about Docker. So before learning about Docker, first of all I would like you to show you how do we create an instance inside AWS environment. I'm doing this because I'm gonna run all the commands and I'm gonna install Docker inside your AWS environment. So let me go to this AWS setup. This is my AWS dashboard and you can create your free tier account here. They give you 1 year free subscription. So in order to create an instance, first of all I should click on this services EC2. EC2 is the elastic compute cloud and it gives us a empty server or an empty PC. So you can come here and click on launch instance. So this is telling me to select an Amazon machine image. That means it is telling me to select an operating system. So here I'll be selecting this Amazon Linux 2 AMI image. Sorry, the first one, Amazon Linux. And the second one is they're telling me to choose the instance type. So I'll go for this free tier application, T2 Micro. Configure the instance. So the number of instances and all I'll be keeping it as default by default. Add some storage. By default it will give a 8 gig of storage and I'm fine with that. Next, adding of the tags. So let us just add a tag called as name. So the name of the instance should be, I want to give the name of the instance as Docker instance. Next comes the security group. So here we should take care of the ports. Here you can allow your traffic. So by default they have already added SSH protocol, but let's say if I want my HTTP port or HTTPS port to be enabled, what I can do is I can click on the drop down and select any of these. But as of now I am not sure what are the containers which I'm gonna launch up inside my Docker machine, and I am not sure which of the ports they will be using. So just for the safety purpose, what I'm going to do is I'm going to add all traffic, and the source should be anywhere. Though it's not safe when you add all traffic, it is not recommended to add the all traffic, but since this project or this instance is just for demo purpose, so I am uh, adding all traffic as my security group. Just review and launch the instance. Now by default I have a key pair named IBM key. What I want to do is I want to create a new key pair. I want to give the key pair name as demo and then download the key and then launch up the instance. So this is the instance which I have created just now, the name Docker instance, unique ID, instance type, all those details. So if I want to get the public IP of this particular instance, I should click here. This is my public IP. If I click on this icon, I can copy my public IP. So now what I want to do is I want to um, launch up this, I want to connect this instance using my putty. So in order to do that, first of all, what you have to do is you have to save a private key. Now click on puttygen, click on load, search for the downloads where you have your key. My key name was demo.pem. Open. Successfully imported. Now what you do is you have to save this key as a private key. Are you sure you want to save this key without a passphrase or protect it? Yes. Now give the name of this private key and it should be in a .ppk extension. So I'll give the name as demo.ppk. Okay. Now copy this IPv4 public IP. Go to your putty. Paste your IP and give the name as Docker instance. Save. Similarly, you want to import your keys also, so go to SSH auth, browse your key, here downloads.ppk demo 1. After that, what you do is you go to your session and again save it. So if you do it after adding the key, if you save it, the next time when you open up your putty, you don't have to add the key again and again because this will be saved already. Now open it. So by default, the user ID for your AWS Linux instance will be ec2-user. Now we are logged in inside the server or the instance which we have created just now. Okay, so this is all about the instance creation inside the AWS environment. Let me go back to the slides. Okay, so why is Docker more important, or why you keep on hearing this term Docker everywhere? So have you ever faced some issues like the same code would be working fine inside a developer machine but it won't be working fine in the tester machine? Maybe because let's say the developer has upgraded its system, or maybe the plugins or anything is upgraded there in the developer machine but not in the tester machine. Then what happens is the same code will be working fine inside developer machine and not in the tester, and there will be some conflict. Okay, these were the issues which we used to face before Docker came into picture and before DevOps came into picture. But now after Docker came into picture, it provides us a consistent computing environment. So that means all the testing and the developers are in the same environment now. So this is the reason, because of Docker we are avoiding all the environmental issues. So now developers get more time to work on fix their bugs instead of sitting and troubleshooting their environmental issues. Okay, so let me go to the second slide. So where does Docker operate? So where does the Docker come into picture in our software development life cycle? So our traditional life cycle starts with the requirement, then the design, then coding, then testing, and then finally the deployment. So Docker operates here in the deployment phase. So Docker helps in the deployment of application in a very easy and efficient way, and it resolves lots of issues related to the environment. Now we'll learn about what is Docker. Docker is basically considered as a world's leading software containerization platform, or you can read in the slide it's written Docker is a tool designed to make it easier to create, deploy, and run the applications by using the containers. Containers allow us to package up an application with all the parts it needs, such as its libraries, its other dependencies, and ship it all in one package. By doing so, this resolves the issue of applications working on one environment and not on the others. And today when we talk about the softwares and all, there are not just a piece of code, it's an entire software stack. It contains the front end, it contains the back end, the databases, the environment, the libraries, the dependencies, and all. We should ensure that all of these component should work in a very wide and different possible platforms. Next is how Docker works. So basically what happens is there is something called as Docker file. So the developer will write a Docker file. This Docker file will contain all the details related to the Docker images. I'll be explaining about Docker file and its syntax in a very detailed way later on, but now you just have to understand there is something called as Docker file, which is nothing but a file which is used to create a Docker image. So developer writes a Docker file, and once we build the Docker file, we get a Docker image. And when we run the Docker image, we get a Docker container. So Docker container is nothing but a runtime instance of a Docker image. These images are normally kept inside a cloud repository which is called as Docker Hub. Docker Hub is you can think Docker Hub as a Git repository for Docker images. So Docker Hub is a place where you can get thousands and thousands of Docker images. So once the image is pushed or image is there in present inside the Docker Hub, this particular image, any anyone or the anyone can take up that particular image and use in their environment. So let me just give you an example. Like let's say I'm a developer and I have written a Docker file with some specifications, and that particular Docker file is built into a Docker image, and this particular image is pushed to the Docker Hub. Now since it is pushed to the Docker Hub, your image is public. Since it is public, anyone from the outside world can pull your image and implement in their environment. Anyway, we'll be learning about this Docker files, Docker image, Docker container, and Docker Hub in a much more detailed manner later on. Let me go to the next slide. The next slide is virtualization versus containerization. So uh, if you go for any interviews or in any interview, this question is a mandatory one. People will ask, what is the difference between virtualization and containerization? Why containers are so much popular? So if you see this diagram, this is the architectural view of your virtualization mechanism, and this is for containers. So in virtualization, you have your infrastructure, then you have your hypervisor, and then on top of that you have your guest operating system, and then you have your binaries and libraries, and on top of that you host your applications. But here in the containers, initially starting you have the infrastructure, and then you have the operating system, and then you have a container engine which is called as a Docker engine. So you don't have hypervisors inside a container. Instead of hypervisor, you have something called as Docker engine, and on top of the Docker engine you run multiple containers and you launch up multiple applications. So the difference between containers and the virtual machines are, first of all, containers doesn't have its own operating system. It takes up a virtual machine operating system to boot while booting up. So since it doesn't have its own operating system, the spin up time is really less. You can spin up any container in just a fraction of seconds, whereas in a virtual machine it takes around 30 seconds to 1 minute of time. And since it doesn't have its operating system, containers are very lightweight compared to the virtual machines. And if I talk about the virtual machines, what happens is you have to give the resource space, the resource utilization, or what is it called? You have to assign the resources in the virtual machines. Let's say if you create a virtual machine, you have to give like 2 CPU is required, or 2 GB memory, or disk space is required, something like that. So that you have to specify, but not in the case of Docker containers. Docker containers will automatically take up the disk or the CPU and the RAM and all, whatever it's required will take it up by itself. So there is no wastage of resources.